Oh, I didn't see it. Oh,
Just everything. How did everything?
yeah. Yeah.
Difference. I look pink.
It's fine. They do something actually. It's a lot like. Here, what, one equation. Stuff like that. It's another one class. Yeah. Have you taken the money? But I knew. On the road.
Oh, I cannot design.
It's got 42 grand. I think.
Okay, that does, okay, I'll see you two later, that's fine.
Much less.
Is it very, very no, I think that might be spots. Like completely. Lights. How about yeah.
I don't see you. Good morning.
So on the board is a intuition by part question. They start by identifying the U and EV. Number which follow the line. You have logarithm. The logarithm has to equal to U. If you have inverse trig, the inverse is the U part. And there's A in the algebra. Algebra stands for power function, polynomial function, I guess. So A stands for algebra, and this one obviously has that's the negative 3x. So I would recommend making negative 3x equal to U. And the cosine 2x dx is a so identify what equal to U, what equal to dv. Then you go ahead, and the u is the one you have to find the derivative or differential. And the dv is the one you have to integrate, because dv is derivative times differential. And then you gotta find the v, which will be an integration process, to integrate cosine 2x. Differentiate the negative 3x and integrate the cosine 2x. Then follow the integration by part, which we will find the answer. Let me see what your answer. Once you answer the question, make sure your card is facing down. Because, yeah, it's pick up images. So I hope that you finish your 5154 review question homework. And I know that 3 homework left, 1 homework that's already closed. But normally, if you request to open your homework, like you've done the calculation, you know the answer, I'll open up for you to submit your solution. Whiteboard does not officially close down anything, even if the homework is closed, you can still view it, you can still calculate the answer. So the question is not completely closed. You can always submit your answer to say if it's right or wrong, but it won't record the answer. You will not get credit for it, but you'll know for sure whether it's right or wrong. This one has a lot of position, so it's very easy to make a mistake. That's right, thank you. Let's try and try to read your own answer with everyone around. That's right. Just to tell like what was the small error. This number, the 3 and 2 are the ones that sometimes cause a little bit issue when you try to. I'll write up the answer. We haven't find the answer yet. We'll do it together. So we'll copy that one over. If you follow what we were saying, we will make the u equal to the negative 3x. And the UDV, right? Integration is now UDV. So dv is equal to cosine 2x dx. So identify UDV. So now the integration is really integration UDV. Because u is the first part, and then the dv is cosine 2x dx. So the u, we have to find the du. The u equal to the derivative times the differential. Derivative negative 3x is negative 3. And then we multiply with 3x. That's this part. The dv, we identify it as already how the derivative multiplied in, because this is a derivative. So we have to find antiderivative. Like if the derivative is cosine 2x, what function is the original? So the derivative cosine, the original answer is sine 2x. But if it's sine 2x, derivative sine 2x is cosine 2x times 2. But we don't have that 2, so we have to multiply 1/2. So it's like a reverse chain. Instead of multiply 2, we divide by 2. So I guess I'll try it with leave a little bit of space. So it's actually 1/2 sine 2x. So 1/2 sine 2x is derivative would be 1/2 times cosine 2x times 2. The 2 will cancel the 1/2. So derivative of this would be cosine 2x. Are we okay with that? Chain rule. So now we have the right UV, UV, follow the integration by parts. So this is really, that is U. So this is a UDV integration. U is negative 3x, dV is cosine 2x dx. So following the integration by part, the answer is supposed to be U times V minus integration V U. So then this original question will equal to U times V. That is this multiplied by this. So these two multiply, we normally try to multiply the number first. So the representation of it will be negative, then you have 3/2. So I have the -3 times the 1/2, that's -3/2. Then you follow polynomial and then trig, so we follow that kind of convention with the writing. So you have the x, you have the sine 2x. So that's the U times V. And then we have to minus integration of V du. The V is 1/2 sine 2x. That's the V. And then the du has -3 and then 3x. So I'm trying to follow everything that we had in that formula. Integration of UDV equal to UV times U times V minus integration of UV. Here we have, we will write whole thing out following that format. The first part of the answer is already done. As far as the formatting, kind of say which one is right, and that it will write among four. Only the first one is right, or is it? Doesn't make any sense. Okay, let me finish the calculation. Obviously, until we have everything done, we won't be able to know which one is right. I still have to finish this part. That's already done. This part needs to be calculated. So we follow. Since that one is already done, I try not to write too much on the board. So to finish this calculation, you see the -1/2, there's -3. So we move the number out of the integration. So this is actually a positive 3/2 as far as the coefficient goes. There's a -3 inside of the integration, there's 1/2. Multiply is -3/2 times negative, so it's positive 3/2. And then we have an integration of okay, find the little dots. So the integration of sine 2x dx. And then we have to find the antiderivative sine 2x, which will be negative cosine 2x. You also have to divide by 2. That will cause you to have a -3/4 from this one. So this one, after we have an equation is -3/4 cosine 2x plus. So this is where we have -3/4 cosine 2x plus c. So that's everything. Finish this integration. With chain rule, you can know the final answer. I hope that's easy enough to understand. No. Just see the slides. Okay, you kind of just switched it, and there's two terms. That's right. No, it's right. I make sure that stand in, but try it yourself.
Oh, yeah.
Okay, you guys can share with each other. So then you know which one is each other's answer. So let's, if we look at more of our calculation, maybe we will be more confident. So let me try again. I feel like we are still having a few wrong answers of scanning around. But let me finish this last part. We already have part of the answer. This is
part of the answer. But then I gotta finish the one last thing, this part. When you are integrating this function, you will have, this is actually still in the integral. So we still have, this is actually a derivative of anything that's not part of the process. So when you integrate cosine, you integrate sine, you have negative cosine, so it's negative 3/2 cosine 2x. The derivative of cosine 2x will give you sine negative sine 2x times 2. We don't want that 2, so we have to divide the 2. That's chain rule, reverse chain rule. So integration of sine will be negative cosine, but then the 2x will cause us to divide by 2. Hope that was okay. So this is the other part of the calculation, the other part of this part. So the final answer will look like this. And you rewrite it, so you can compare. It will be, the final answer is negative 3/2 x times sine 2x. And then there's a negative here as well. So it's negative 3/4. A 4 coming out from that 2 times 2 is 4. So negative 3/4 and then cosine 2x. Okay, and then that's plus c. CC. So then you can see the x times sine 2x should have a negative 3/2, which is, this was right. Well, there's no 3/2, so that one was wrong. It's not 3, it's 3/2. This one does not have the x, right? There's an x here. So that one was wrong as far as the sine part. And this one, there's a 3 in here, that's wrong. We only have a 2x, there's no 3x. So this leaves us only, okay? So this is a negative 3/4x, which is what we have here. So I hope that we're sure about the comparison of the two. All right. It basically is going through the whole process of comparing and integrating. I hope that you are on the same page with me. The final answer should be D. This is the example of integration by first. And, do you have any questions on the you're gonna see if your name is, recorded. Let me show you collectively what we are. Okay, William. Okay. You wanna, write this, let me see if I open it. Okay, that works. Anyone else? Hope everybody's attendance already recorded in the solution set. Okay, so the final answer should be D. It's integration by part question. My writing is not perfect, but I hope that I explained the process of the calculation. The determination of U and V is helping us to follow the formula of integration by part. So then the process starts from here, and this is the calculation. I didn't copy this part because I feel like the U times V part is already done. So we follow the integration of U. This part we have integration of the trig function. Any question? All right, homework. What for homework? Any question or any? Yes.
Could you work out number 16 on the 5.4?
5.4, the first one?
The one that wasn't closed.
Okay, I see. If we still have questions about that, maybe I should reopen.
5.5.
5.5. Okay.
Are they always available to go back? Like,
If you already have the answer, I can reopen them. But right now, they're closed, but you can still see it, right? This is a student, you can still see the question. But if you have the answer, I can reopen, you can submit it like very quickly. But if you don't have the answer, there's no point of keeping it open. You know what I'm saying?
Yeah.
Right now, you can still view them. You can still submit and see if your answer is right or wrong. but you won't be able to get credit for it.
Oh, yeah, I was just talking about like setting actually you've already done, it, go back.
Yeah, after you finish working on it or already have a pretty definite answer, you can let me know if it reopens so you can get credit.
About it.
You finished?
No, I'm not done yet now.
Okay, yeah. Let me know when you want to open any of the past assignment. I set the due date so that we can have a motivation to finish on time. So I give at least a week for every assignment. If past that way, 1 week, you want to reopen, I can still do it, but I'm just trying to make sure that you know the answer to submit. You were saying number,
16 on 5.5. That's the other, it's the other one?
oh, let's see. Is it this the one?
Yeah.
Okay. Right, this is a substitution question. I think what we did, on my, it says that one, that you do, see?
Yeah.
So we follow that suggestion. We identify you. Okay. Right, so following that suggestion, we would say that let's make u equal to this. If we do that, then du would equal to. The du is a differential, the du means we have to find the derivative. If you find derivative of a exponential function, it will be the same, but you have to multiply. So the derivative of e to the 2x will be e to the 2x, which will be the derivative of the exponential function. But then the 2x also, 2x is a inside function. It's a substitution, so you have to find derivative of 2x, which is equal to 2, and you got to multiply. So it looks like this is 2 times e to the 2x. So this is normally how do we differentiate exponential function? You have to have the function itself. That's really fundamental because exponential function's derivative will always be identical to itself. But then you have to multiply the derivative inside function, which is why we time 2. So same thing with the second part. When you try to find derivative e to the 2x, it will be e to the negative 2x. But then you have the derivative differentiate the inside. Derivative of negative 2x is negative 2, and you have to multiply negative 2 with the whole thing. So the second part will be negative 2 times e to the negative 2x. So then basically this original question after substitution, we should multiply du. This is multiplied by dx. So that's our du. So this original question becomes equal to the denominator is a u because of the u substitution. The numerator is this one times this one, which is exactly this too. So that is really the du. So numerator equal to du, denominator is u. Right, that's really an integration of 1 over u. The integration of a reciprocal function equal to the natural log. So this is natural log after u plus c, and then the u equal to that summation. So final answer will be natural log of e to the x plus e to the negative. There's a 2, right? E to the 2x negative e to the negative 2x plus c. So pretty much how it looks like. And I'll go back here and see if that works. Because natural log exponential function are all positive, so we don't have to do an absolute value. So e to the 2x plus e to the negative 2x and plus c. That's a definite integral. I see. Thank you. So we should plug in the number. We will plug in 1 for x. That will be when x equal to 1, 2x equal to 2. 2x times x equal to 1, 2x equal to 2. Right, so this is the upper limit minus the lower limit. Lower limit is the same. I got to put in parentheses today. That was a parenthesis. So it's the same calculation when x equal to 0, that was e to the 0. So it's natural log, and here you go, e to the 0 plus e to the 0, since e to the negative to time. But e to the 0 equal to 1, so this is really 1 plus 1, and that would be natural log of 2 at the lower limit. This is definitely integral. I just noticed I just did the integral calculation. So that's why you have a question. So that you have the same answer? Do I have the same answer? I see.
Yeah, I tried it about 13.
Okay, yes. Oh, there's two.
So.
Right, so it was a typo on my part.
Sorry.
So I see you see the problem on this. I say, this is you, when we do a substitution, the numerature does not have the two. So numerature e to the 2x minus e to the negative 2x, these two multiplied does not equal to the du, because you have a 2, right? Right, so we should divide those by 2. So I missed a 1/2 there. Where is that? Yeah, see the dot. So we divide this side by 2 and divide this by 2. If you divide both side by 2, the right side would be e to the 2x minus e to the negative 2x dx. Because we divide out the 2, the right side is going to be 1/2 u. So what really is the numerature, this one time that one, that was really too basic. This one time these two is this, it's equal to 1/2. So there's a 1/2 that we should bring to the outside of the integration. So then the final answer should also have a 1/2. Those 1/2 natural log of e to the 2x plus e to the negative 2x. So our final answer also should have a 1/2 on the outside. It's 1/2 this natural log and half of this. So 96 is in the substitution. So when we are substituting to get to divide 2. Did that work out your version of it? So let me, we have identical questions. Do you have the same or slightly different ones? I have the same. Thank you for mentioning that. I didn't caught that. Back to the calculation. This is only calculating the indefinite integral. To calculate the final answer, you have to take that calculation. You have to make x equal to 1 equal to 0. So we were supposed to calculate 1/2 natural log of e to the 2x plus e to the negative 2x. We gotta calculate x equal to 0. Also calculate this function when x equal to 1. So the final answer is going to be 1/2. I thought it was an easy enough question because there was already a hint, but 1/2 natural log e of 2 plus e of negative 2 minus the lower limit, that's 1/2 natural log of 2. Because if x equal to 0, e to the 0 equal to 1, that's 1 plus 1, that's natural log of 2. So that's the final calculation. Any other questions on the homework? Okay. So let's try to finish our homework on 5.5 and 6.1. If you have any questions on 6.1.
Yes, number 4.
Number 4, 6.1.
Yeah.
This is a integration by part question. Typically we'll identify the U using the LIATE. This is, the E is exponential function, the T is a polynomial, or power function, which is a. So the T will be the U, the E to the negative T will be the dV. So, solution. So with that, we first say, U equal to T and dV is equal to E to the negative. Try to avoid my handwriting. It's not very pretty since I'm using the computer mouse for writing. So that's a U and dV from the original question. Now it's integration of U dV. So the calculation, we gotta find out the differential for the U. Derivative of a single variable equals 1 and then 1 times the T, because we're analyzing the differential. On the other side, the V is already in the differential, so you would find the antiderivative to be equal to negative E to the negative T. Right, derivative E to the negative T is E to the negative T times negative 1. So then the antiderivative comes. So this part, are we okay? That's already the UDV part. We're gonna find the answer for the indefinite integral before we work on the definite integral. So the indefinite integral T e to the e negative T now become integration of UV. Since that's the U, that's UV. Now, according to our integration method part, this equal to UV minus integration of the U, which essentially is reversing the letter before and after the D. So we become before the D, we switch them, you become after the D. So we expand this U and V, that is U, that is the V. Multiply these two, you get negative T. And to put the negative before everything, so negative T times E to the negative T, that's U times V. And then we want to minus integration of V du. V is E to the negative E to the negative E to the negative T, that's the V. And the du equal to dt. Okay. And we have a negative behind the integration, and we have negative before the integration. These two combined is a summation. So our antiderivative is, going back here, the antiderivative is negative T e to the negative T plus, this is a plus, but then our integration to the negative T dt. Integration of this is going to be negative e to the negative T plus C. And of course, we also got that. So it should be negative e to the after the integration, we still have that negative. So negative e to the negative T. That's the antiderivative part. We then have to calculate the value for the definite integral. We calculate when T equal to 2 and also when T equal to 0. These two numbers, after they are calculated, you have to subtract them. So if you plug in 2, you get negative 2 e to the negative 2 minus e to the negative 2. So that's what happened when T equal to 2. And then what will happen when T equal to 0 is T equal to 0 in here is negative 0 times negative 0. That's 0 because the T is multiplied. Anything multiplied 0 equals 0. On this part, e to the negative 0 is e to the 0. E to the 0, check with your calculator, any number to the power 0 equals 1. So at lower limit, the value is negative 1. We were supposed to minus the lower value. At the lower limit is negative 1, minus negative 1 is actually plus 1. This is plus 1. This can be combined even further because that's negative 2 e to the negative, that's negative 1 e to the negative 2, combine them. Yes.
I thought the term was supposed to be you and not man. I mean, the loop. I thought the links were supposed to be you, and they're an X that.
In the substitution method, U and BV, those are just notation.
Okay.
So when you derive them, you have everything represented in T, which was the original.
The X are like the two. But if we're doing you.
The 2 and 0 are supposed to be the T is. It's in the original integration, so the 0 and 2 are representing value for T.
Yeah, when do you have to change it into U form? U equals to U, or something, the numbers change.
The number change is when you do the substitution method,
Just read.
you will change the integration.
And you plug it into the original U, right? And that's how you get the.
Right, you plug in the.
Like the U equals T or the U equals X squared.
Right, right.
Okay.
So it doesn't affect this one, since we're doing integration by part, although the U and V are assisting deriving the final formula. The actual integration is still in the original.
If you had to use U sub in the beginning, would you have to change the variables, the limits?
I normally prefer changing it back to the original variable, use the original variable one. Because I prefer not to change the value for U. If you are using U sub, I will write back to the variable. If I have U equals something, instead of finding the value for U and if you lower than that, I would never U, I will still use T.
Did you don't want us to ever change it into U value?
I could do it, but I feel like that's too, there's a too pure work. I mean, when we see a substitution method, we can try, but this one is not a substitution.
Okay, what I'm learning from always tries to get me to change it to U.
Let's see.
I was confused.
Those are the words. But this one is not a substitution, so it doesn't really apply. So this one, we are using T as a final answer. After we combining the variable, we will actually have -3 e to the -2 plus 1. See if I didn't make any calculation error here. So it's -3 e to the -2 and then plus 1. Check. -3 e to the -2 power 1. That would say question number 4. This was the integration by part assignment. Most of the questions we use integration by part, or occasionally when the questions are difficult, we have to do substitution to in the middle step, but not this one. Yes.
You do a question on this one.
Okay. Question. As you can see, one part of it is polynomial. Polynomial would mean there's multiple terms. Polynomial is a combination of the power function with different power. Power 2, power 3, power 1. Combining all 4 functions, we get a polynomial. So that one gotta be the U. Because we normally do the one that's easier for differentiation. This one we want to differentiate. This one's gonna be the dv. And it's similar to what we just did. Oh, that one's gonna be several parts. Okay. All right, so this one is gonna be a little bit lengthy with your integration by part with U and V. So I would recommend following something called table and method. I was gonna talk about it today. Let's see. The tabular method I mentioned, posted a delay for integration by part. Now, when you do integration by part, occasionally when you have all right, maybe we should compare that. For example, the one we just did. So this is already done. The calculation down here, we had a integration by part method. So we'll try to use tabular method also do it. Tabular method definitely is shorter. Watch that video if you want to see more example. And here we're going to use this one as example. Basically, this is how tabular method works. You want to find the antiderivative of this function. So instead of labeling u and v, we identify which part we want to differentiate. V is the u part, and which part we want to integrate. So the I is for integration. And here we're going to look at the sign. When we are integrating using the integration by part, we have this part is the one we have a positive sign, but this part we have a negative sign. So there's a alternating between the integration part and the differentiation part. So then positive sign and negative sign. If you have to apply the integration by part again in a new integration on the right side, there's a positive and negative. And if you have to repeat the integration by part several times, that's why the tabular method is better. Because in the tabular method, if you have a higher power function that you have to integrate, you have to differentiate, do it in one setting. Instead of this, you only get to do integration by part one time. If this one has to integrate again, you have to have another u and v. So another u and v. So you have to have pair of u and v keep going because of power. Right now, this one has power 1, so we don't have difficulty in it. Let's do bring some easy calculation. So we start with positive and negative and positive. Now start with the one you want to differentiate, which is a t. So we find the derivative of t, which equals 1, and derivative of 1, which will be 0. So this, the one you are differentiating, you will always be differentiating. The one we're integrating is this one. This is a dv. That we call, so this is the part that we keep integrating. But you're gonna, if you are applying integration part by part multiple times, you'll be integrating multiple times. But with the tabular method, we can combine all those applications in one table and follow the table. So for example, the one we're integrating is e to the negative t. Integration of e to the negative t is negative e to the negative t. And then integration of e to the negative t again. So we're going to integrate this one again, which will be negative, negative, which will make it positive. So then we have e to the negative t. All right, what's the outcome of this is an integration, the tabular method. This method only applies if the differentiation comes to a stop, which is 0. So you can see the integration never stops. Integration, you are bringing the power higher and higher, but the exponential function is okay because it doesn't go up in the level of difficulty. But the differentiation, as you're differentiating, it gets easier and easier. Function eventually come to a 0, so we don't have to work on anything else. Well, now the final thing is after you finish differentiating and integrating, now you can follow the table for how you write your answer. So our answer will be, you start from that positive sign and this t, and then you go diagonal down here. Okay, so that will be the first term. It's negative t, and then there's negatives from this negative t times e to the negative t, and that's the same as what we already have. That's the u times v. So these two multiply is u times v, and then we follow the same thing. The second layer of calculation, you have that negative sign times the 1, and you go diagonal down to here. Okay, so that will give you a negative e to the negative t. And then we're finished, because if you follow the diagonal, this is 0. 0 times anything is 0. Following this, the remaining term will always be 0 in the second column. So we stop in the table. Are we okay? If you go watch that YouTube video, you see more examples. I want to use this one since we already did the table, the classical method. We're going to compare that with the classical method. You can see once the table is done, the answer for the antiderivative is it's the same thing. But it's a little bit faster as far as the time that it can hit, especially when you have to apply integration by part multiple times. The table method is better. It works better when there's a power function time, polynomial function time exponential function, or polynomial function time trig function. That's normally a scenario. the table one method does not work if you have a trig function times exponential function, which we say earlier, since you have to apply table integration by part multiple times. But the two column, none of them stop, right? Differentiation will be forever, integration will be forever. The whole process will now give you a way to wrap it up. And but this we get to stop. So let me try to go through this example. So we actually are gonna see how it works. Are we okay so far?
On the table, is it only the differentiating column that needs to stop, or can the integration column stop?
The differentiation is the only one that comes to a stop. Because the power goes lower one by one. Eventually the power goes to zero. That's why it becomes zero. But integration raises the power, so it doesn't stop. Yes.
Is the last the integration is
The- We always start with plus. It's plus minus plus minus plus. So the first column for the sign, it's always the same. We label there just so we don't miss the negative sign. Yes.
the last one is a plus. Do we have to use a plus?
So we can look at that table again. So it's plus minus plus. You can see the third one will follow that sign, but it's not being applied. It's just a zero.
So that's another.
It doesn't really matter. But it matters if this middle column has more things. Middle sign has to be applied.
Oh, it's just really.
Yes, it's plus minus plus minus. If it's a zero, then we really don't have to do that sign. I don't know if I misunderstand you. We'll see. Let's try another example to see how the table method works. So let's try to see, maybe with more practice, we'll kind of figure out what we're confused about. I mean, all right, let's try this equation. If this integration really, if you have to do the tabular method, because if you are using the typical integration by part, you end up have to do several times or several integration. There's one, there's two, there's three. This one, 9 times e to the negative x. It's not difficult to integrate. Integration for the last one would just be -9 e to the negative x. That's the antiderivative. This one times that one, then we have the -7x times e to the negative x. That one you have to do integration by parts one time. But then the 5x squared, do it at least 2 times, right? The power kind of dictate how much time you have to apply the integration by part. And we're doing it all together. So here is what we're gonna do. This question definitely will be easier with the tabular method. We have, this is a column for the signs. We go plus, minus, plus, minus. There's a power 3. So make sure I have enough column for it. All right, the middle one is that this polynomial. All right, I'm gonna put it right here. All right, this is the one we are going to find the derivative for. All right, and the other one, that's the dv, and that's the one we're gonna integrate. I for integration, we have e to the negative x. So we're gonna do it in a tabular method. Make sure the table is clear. So we're gonna find derivative of the middle one. So derivative of 2x cubed is 6x squared plus 10x minus 7. Differentiate one more time. We're gonna get 12x plus 10. And one more time, we're gonna get 12. And then one more time, we'll have 0. That's where we stop. Okay, so then we work on the third column. That's what we are integrating. So we have negative e to the negative x. Integrating this one more time. You're going to have a negative from the e to the negative x. So negative and negative will cancel. So you can see the sign alternate to go positive, negative, positive, negative, positive, negative. Because there's a negative e to the negative x. So this is e to the negative x. It's negative e to the negative x. X. It's always e to the negative x, but the sign on the outside changes. So then let's try the final answer. we follow the sign and this one, and then times that one. So this, there's a negative sign there, so the overall thing is going to be negative. So it's negative 2x cubed plus 5x squared minus 7x plus 9. And then e to the negative x there. And then the next thing is this sign times this one, and then you go diagonal. In this, if you multiply, so you have that negative, otherwise we're probably gonna get negative. So it's negative, and then we have 6x squared plus 10x minus 7, and e to the negative x. Okay, and next one, we're gonna do a positive sign time. This one is diagonally, we multiply this. And there's a plus sign on the sign, but there's a negative over here, so it's still a negative. So it's negative 12x plus 10 and e to the negative x. Last one is when you have the 12 times this, and there's a negative sign, so it's actually negative 12 e to the negative x. And we're done. And that would be the final answer. I hope that you're with me. Okay. All right, now it's time to answer. Realize they all have negative and they all have e to the negative x. So maybe we want to write it easier if we want to enter the whole function onto what work, maybe combining next term. Combining like term, we have less term to enter. So we're going to have large. Right, we're gonna have negative e to the negative x. You factor that outside, and then that's everything inside. Negative e to the x, you bring that to the outside. And then what's inside? The highest power is degree 3. So we have 2x to the power 3. And then we have degree 2. X squared, 6x squared, 5, 6. And that's it. So there's only 2 degree 2 term. You add it together, that was 11x squared. And then degree 1, negative 7x and x, and there's 12x. 22 minus 7, 15x. All right, and then what we have left, number. So we have, this is the plus 10, there's 12, there's negatives already out. So 12 is plus. 12 plus 10 is 22, and then minus 7, and then plus 9. So overall is 22 plus 2, that's 24. Here plus 24. So that's everything combined. You might have a different version of this question, but at least for this version, and that will be the answer. Okay, you can try to calculate the derivative of this, which should confirm the combined, after combining like term, it should be that way. I hope this answered your question. Any other question from this section
Yeah, number 14.
of this thing set? Thing set 14 of this assignment. I said we did, this is the 14. Just did. Any other?
11.
11. Okay. Question 11, this one? Oh, wow. A higher power there. First, we probably need to do a substitution. Make u equal to x to the power 7. And then let's see what we go from there. This is a question 11, has a higher power inside the trig and outside the trig. So because the trig, we typically prefer having a simple term, at least lower degree inside the trig. So the first thing you can do is make u equal to x to the power 7. So then the du would equal to 7x to the power 6 dx. Okay, so now we're gonna do a substitution. Substitution changes your integral and also change your variable. Integration by parts does not change the variable. So this is going to change to a cosine u because u is the whole inside part. And then the x to the 6th power dx will be the du. So we're gonna separate this. We're gonna go cosine x to the power 7. Here you need x to the 6 to the side, so x to the 6 dx. And then we have x to the 7. Okay, so the x6 times dx is going to be 1/7. You can divide the 7. So that's the x6 times dx will be divided by 7. So 1/7 du. This two together, these two together is going to be 1/7. So 1/7. And here is du. Now that one will be the u, integration u cosine u dx. So after substitution, the integration is this. Are we okay about changing the variable? Any question?
Separate the x 13 to make it x 13.
Yes. I rewrite it. So then the x to the 7 is the u, but then the x to the 6 in x will be the d. Well, what do you have? You might have different colors, right? 5, okay. But whatever is inside the cosine, inside the trig, should be your u. And then you're gonna try to create whatever that one from the outside.
Try to put that sign.
We're trying to make sure the cosine inside the cosine is a single variable. So whatever that power is, that's here. And that's from there, we will find it in u. From there, we're gonna rewrite that one according to the variable. Any question? After that is integration by part. You can also do the tabular method for this integration. Yes.
So just by looking at this problem, we can tell
When you look at it, when there higher power inside the trig function, you are forced to do a substitution because this in itself we can't integrate it without the substitution. So the purpose of substitution is to simplify integration. Also make the trig function make it into a single trig instead of 5 trig. Right now that's a computation function. Normally with computation function, we always do a substitution. I hope that kind of, yeah. So it's a clue or kind of a way to handle computation function. If we have a complicated function with another complicated function in there, we prefer having the inside equal to a new variable, so that we can handle it on the outside. So this is really forcing that part. This inside is now simpler, so then the outside have that extra thing. But I think this outside have a similar, the outside is a polynomial, inside is a polynomial, making that equal to u, actually simplify the inside and outside. So then the whole thing have a lower power, because you're making a higher power into a single variable, all the higher power terms get to reduce. Yes. What do you mean? Normally, but I keep it 10 questions per section, for the review question we have more. Okay, are they? Most of the web group questions, since they're calculations, they're free response. Any other questions? I don't, let's see, I was trying to finish what we started on yesterday. So we have 1/2 of the trig integration and we need to finish. So let's try to review. 6.2, we focus on when you have a function, when you have to integrate a trigonometric function, what do we do? And this is what we already talked about yesterday. Hopefully we can go through this faster. Since 5.4 and 5.1, we went over some of the integration of trig function. So we have 6 trigonometric functions. We're able to integrate every single one of them. And then second, we need to know how to integrate a higher power of trig function. Let's start with degree 2. These are a couple of scenarios. In 5.5, we're able to go through 5.1, 5.5. We're able to go through some of the integration of degree 2 of trig function. And this is also, if you have a derivative formula, you are able to integrate it first. So these are the one we already mentioned. So starting today, we should be able to integrate sine squared, cosine squared, tangent squared, cotangent squared. So these are the one we start looking at. So yesterday we started to talk about integration of sine to a higher power, cosine to a higher power. How do we do it? The strategy is look for odd power, so that will be our opportunity to use substitution. So if m is odd or cosine is odd, from that odd power, supposedly as a higher power, you can take a degree 1 of the sine or cosine as a way to use substitution. And if cosine x dx, that means u equal to sine, so the du will be cosine. If you have sine x dx, that means u should be cosine, so the du will be negative sine prime dx. So then this part of whatever multiplication dx is indicating the derivative part, and therefore you have to integrate, find your u substitution. On the other side, if you don't have any odd power at all, if they're both even, we have to reduce the power, reduce from an even power down to an odd power, and then probably apply the odd power scenario to finish the integration. So here we have, that's the power reduction formula. From that, we realize that a higher power, square power of cosine or sine, cosine square or sine square can be rewritten as degree 1 on the cosine. If the cosine is degree 1, we can integrate that into a sine function. So this was the formula that we go through yesterday for how to integrate sine square, cosine square. And that was the first example where we have a odd power together multiplied by even power for cosine. The method is really factor the odd power. Now we have a single sign over here that made it possible for us to do a u substitution. U equal to cosine, so the u equal to negative sine x dx. That's our negative u. So then we substitute this is a u to the power, the sine to the fourth power can be extended for us to write the u sub. And after everything is represented with variable u, we're able to finish the integration using the power rule. That's what we did yesterday. And we finished the integration with the power rule for integral, and then we write back to the original variable. Now, if they're both odd power, you have two different methods. You either factor out the power 9 of cosine or factor out the power 5 of the sine. So both methods provide you drastically different answer, but they're both correct. And we prefer keeping the higher power and rewrite the odd power, rewrite the lower power if it's possible. All right, and then we have, if you have both of the cosine and sine are even power, we will do power reduction formula. And if after the power reduction formula is one still have higher power, we will have to extend it and then look for ways to find it out and look for ways to integrate it. Now the odd power, we follow the odd power integration. That one was also odd power. We can find the antiderivative. The cosine square is the one we have to apply power reduction formula. We finished integrating them one by one. And now when we did a u substitution, because this is the odd power, we can do the substitution. And finish that, we will be able to fill them all in. Okay. Now we will finish continue from that. What do we have multiplication of sine and cosine for different angles? So when the angles are not the same, we have a little problem. Normally, when we have the integrated multiplication of function, we have issues. And the issue is even harder when they are not the same angle. If they are the same angle, we'll be able to do a u sub, right? U equal to this, and this is the derivative. But it doesn't work this way because they have 5x, right? Different angle. So derivative sine will be cosine 5x. You never get the cosine 2x out of it. So these two are unrelated angles. So we have to apply something called the product to sum formula. This is something we learn in pre-calculus. I keep getting people ask me in pre-calculus, why do we have to remember these formula? I guess one of the purpose will be here in the integration. If the function of different angle are being multiplied, integration will be impossible. So what we're gonna do is we apply formula. This equals summation of these two terms. If it's a summation, then we can integrate this one plus integration of this one. So being able to write a multiplication into summation or subtraction made it possible for us to calculate integration easily. If we think about it, it also makes differentiation easier. If you want to find derivative, and you can find derivative, if it's a summation, you can find derivative one by one. So when they're multiplied, you have to do product rule for differentiation, which will be slightly harder. So anyway, among the four rules, you can combine the first two together. Because the first two represent if you have sine and cosine of different angle, what do you do? So this, we use A for the first angle, B for the second angle, but if you switch this could be the first angle. So the first two equations are essentially the same as sine A plus B plus sine A minus B. So here is sine A plus B, the summation has no difference with this one. If B was the first angle, so this will be sine B minus A, which will be negative A minus B. So it's just two essentially to me is identical. These two are different. If you have multiplication of two cosine, it will be summation of two cosine, cosine plus cosine summation and cosine subtraction. If you have multiplication of two sine, it will be a subtraction between the two cosine. And remember the subtraction is first, and that will be the product of some formula. Any question? So we will apply a formula, see how it works. See, this is the one that we intend to calculate. And this is definitely a sine something times cosine something. We apply the first formula. So let's write down that formula, see how we apply it. Basically, we're trying to do A is 5x, B is a 2x. So we need A plus B, that means the 5x plus 2x. That would be the 7x. A minus B, which would be the 5x minus 2x, which will be the 3x. So essentially, we're applying the product to some formula, the first one, which allows to rewrite our equation, rewrite the integration. So it's one of the popular method in mathematics. If the question cannot be done, either you write it into break them down to a small question or rewrite it into something else, or you lower the level of difficulty until you can solve it. In this one will be the first scenario, which is rewriting the question. Now we can do the integration one by one. If you're integrating the sine 3x, the antiderivative is, I need to think. Sorry, that was wrong. Why did I write it that way? It was like, but there's not so the editing was wrong. That was supposed to be right. That was supposed to be the integration process. Integration of sine. I was like, what happened to the division? When you are integrating, you will have a cosine, right? It was supposed to be cosine. Integration of sine should be negative cosine 3x. That's why we have the 1/3. Integration of the sine 7x should be cosine 7x divided by 7. Negative cosine. So it should be cosine and cosine. I think it's bad editing on my part. But the final answer was correct. It was supposed to be cosine in the second row of the write-up. So the first equation is to use integration, use the product to some formula, use the formula we have there to rewrite it into two separate integration. And second stage is integrating. Integration of sine is negative cosine. I would be wrong, but I was keeping that sign there. This integration of sine 7x should be negative cosine 7x divided by 7. So the second row was wrong, but the last row was right. I didn't know what happened when I was editing it. The fraction 1/7 was and 1/3. I think I changed it from the first row. I forgot to change the function part of it, only changed the coefficient part. You see what happened there? Do you have any questions? It was cosine the second rule. Sorry. I was writing the whole thing up. I did it too fast. Any question? This is the final answer in the last row of the write-up. Any question? So this is using the formula to simplify the integration, so then we can do the integration by one. All right, this is a part, I'm not sure if that's sufficient time for this. We have at least 10 minutes. Let's focus on how to calculate integration of tangent and secant. Number one, if you have secant square is the derivative of tangent. So if you integrate secant square dx, the antiderivative is tangent. So secant square is integrated by itself. That means if you have even power in the in the n. So secant to the nth power of x, if n is even, we already have a option for a substitution method. That is, you make u equal to tangent, so then du will be secant squared. If n equal to even, you have a natural way to do a substitution method. Another thing is if m is odd. If m is odd, assuming we have a non-zero number in the end, in that case, we will have a secant times tangent dx. Secant times tangent is derivative of secant. So secant could be our u, and then do u substitution where we can finish the integration. And then I'll leave us some of that's only two options, like n equal to even. I cover two scenario, and equal to odd. I think we cover only one here. Right, and other combination. What if the n is odd? This one is odd, so that we cannot substitute the tangent there. What if n equal to even in the same time? And that means we are not able to do either the first one or the second one. So what do we do in that case? We have to apply the formula between the secant and tangent. We're going to convert all the tangent into secant and try to do integration apart from there. So that will be a more complex scenario, the number 3 scenario. Last one, if m is even, but n equal to 0. So this one goes away. You have a higher power tangent of even power. How do we do it? In that case, remember secant square and tangent square have a relation. Tangent square of angle plus 1 equal to secant square. So that means any square power of tangent can be converted to a secant. You see, we have a tendency to convert from tangent to secant because secant is easier for integration. If you have integration of secant square, you naturally have a tangent. So from there, we were able to rewrite the whole calculation and do a substitution between the two integration. And we follow that we will do a substitution or integration apart from there. So now when we were talking about all these strategies, underneath we have this a couple of things we remember. Derivative of tangent equal to secant square. That means integration of secant will equal to integration of secant square will equal to tangent. Derivative of secant equal to secant times tangent. That means integration of secant times tangent will equal to secant. So we have something that to remember. The strategy 1 is because the first equation, strategy 2 is the second equation. Lastly, and this is called a Pythagorean identity for tangent secant. 1 plus tangent square plus equal to secant square. So that allows us to convert tangent to secant or from secant to tangent. These three are something that's really useful when we're doing the calculations. And at least need to finish one example. So we're trying to put them into a tabular format. Now, if you have a higher power for tangent power times secant power, we will get the power number 1. If you ever have even power n be 2, 4, 6, you have even power of secant, you can always do u equal to tangent. That means if u equal to tangent, this is u to the power n, and this part becomes a secant square goes to the du, and then the rest of the secant can be converted to a tangent using the tangent square equal to secant squared minus 1. On the other hand, now what if the n is odd? If n is odd, you can look for m. If m is odd and n is also odd, you can do u equal to secant because tangent times secant is a derivative of secant. So we're able to integrate into a secant. And then leave us one scenario. You can see that it's longer. The third scenario of the whole strategy is this is odd. N is odd. Secant has an odd power. Tangent has a even power. And I was making it hard. And the method will be doing integration by part. And we will probably have to deal with the tangent square using secant square minus 1 as our formula for the conversion. And we probably are not have sufficient time to finish all. Maybe we talk about one example. This is the first example. If you can see the secant has even power. So strategy number 1, if secant has even power, we will make u equal to tangent because secant, I can bring a secant square out of the secant even power. So this is what we're gonna do. So the second scenario, secant is even, and tangent is also even, u equal to tangent. I'm gonna do this. So you have an even power in the secant that allows you to factor secant squared. And then you're left with secant to the 4th power. And we are going to do u equal to tangent of u equal to secant squared dx. So here we have secant square x dx is du. And that's u squared. And what happened to the secant to the 4th power? I guess we have to analyze it. Secant to the 4th power, tangent squared plus 1 equals secant squared. So secant to the 4th power is 1 plus tangent squared. The tangent is u, so that's u squared. So spin that, we get that's u squared, and that's 1 plus u squared. That secant square x dx is our du. So that substitution is done. We go from variable x to variable u. That's u substitution. In the u substitution, you change your integration variable. Again, just want to repeat that because they look very similar. Both of them have u. The integration by part do not have the variable change. The u and v in the integration by part is only assisting the transformation of the integration, but it's really change under. We okay so far? We okay? You're gonna have to expand the square part. So the 1 plus u square, say a plus b square. So 1 square is 1, u square is u to the 4th. And then we multiply these two as u square and then double the u square, it's the middle one. So that expand the square part. Sure. Right, the outside have a u square, we multiply the u square to every term. And that make into a polynomial of u. And we can use power rule to integrate this. So our integration allows us to follow raise the power. When you integrate a power function, it raise the power, and you also have to divide the power because the any question. From there, we have to revert back to the original variable. That was the final answer in the book. But it didn't have a lot of the middle steps. I was trying to fill in the middle so we can see the process of it. Any question? We only get to finish one of these. Almost as spoke to. That was one example, the first scenario, and we're probably gonna finish the rest tomorrow. But in the meantime, you should try to start your 6.2. If you run into any difficult question, we'll work on them together. But in the meantime, let's try to keep up with the homework. I know this is one of the class who complaining, hey, we have to say this many homework questions. But remember, if you have any difficulty, you can bring that to me. I'll work with you. And I'll do as much detail as possible. All right. I'll see you tomorrow. Thank you.
You know, like.
Right up on the answer. Okay. Tell me the answer.
So we're not gonna do.
I think Kendra was great to you know,
Yeah, but.
I don't know.
Oh.
I was gonna ask you about it.
Yeah, the question was still there. So open is, you'll do some calculation, you can still submit. If it's right, it will show you. Correct, but then there's zero, it won't change the grade.
Yeah.
But once you figure out the right answer, you can let me know. I know the answer for those, and let me submit it. I'll reopen it, you can submit it in one day, if you already have the answer. In the past, I've opened it for, time to never put in anything. So I prefer, you know, the answer, and I'll open it, and then just put in the answer, and, then you will, it pops up in one day, but everybody. Okay, yeah. So let me know if you already have the answer, or if you need help. So, thank you.